This section addresses one of the quickest ways to encounter issues in QML, unqualified access, and one of the simplest ways to avoid them. Unqualified access occurs when you reference a property outside your current object's scope without explicitly specifying which object it belongs to. In earlier versions of Qt, referencing properties of the root QML component without qualification was possible. You could also reference the ID of an object outside of the QML file, as long as you knew it would exist somewhere in the parent QML tree at runtime. However, this practice is risky and will inevitably cause your code to break. Since Qt 6, the tooling actively discourages this behavior, so it is best to avoid it entirely. Unqualified access carries a performance penalty because the QML engine must determine which object the property reference is referring to. This process is both slow and prone to errors, especially if the intended object isn't present. Component portability also becomes risky due to incomplete encapsulation. If a QML component is refactored or moved within the application, property resolution that relied on unqualified access may end up pointing to a different object or result in a null value, leading to bugs or failures. Furthermore, unqualified access imposes a maintenance burden. When a component relies on external components outside its scope, it creates dependencies that must be manually maintained to prevent breakage. Type safety cannot be ensured either, as there is no guarantee of what type the unqualified property will resolve to if it resolves at all. This ambiguity limits the effectiveness of tools like code completion and QML lint, which cannot provide meaningful support when they have no information about the intended target. Moreover, QML files with unqualified property references will not compile with the new QML compiler. In summary, always qualify your property bindings with a QML ID to eliminate confusion and ensure that your code remains functional in future updates. The upcoming examples will illustrate different types of unqualified access and provide guidance on structuring your QML code to avoid them. Avoid implicit lookup in the root scope. When referencing properties, always explicitly qualify the object they belong to, unless the properties are within the same object. Failing to do so can lead to issues if another object gains a property with the same name. Consider a small example where a new integer property is added to the application window and a new item binds its X property to this offset property. This code does not specify which object owns the offset property, leaving room for ambiguity. If item were ever to acquire its own offset property, which is possible with versionless imports, the code would misbehave silently, resolving the offset to its own property rather than the one in the root scope. Similarly, any context properties injected into this scope, such as in a delegate, could also shadow this property. The solution is to make the binding fully explicit, ensuring it remains unaffected by any changes to the object or any injected context properties. Additionally, explicit bindings offer faster resolution. As the application window currently lacks an ID and we want to reference it, it is advisable to assign it an ID. In the new item, explicitly qualify the offset binding using this ID. This approach not only makes the binding faster and immune to future changes, but also ensures it is fully resolvable regardless of QML structure changes. In essence, avoid relying on root scope resolution, it may eventually be deprecated. Avoid referencing objects outside the component. Sometimes, components might reach outside their own scope to interact with or modify properties of external objects, assuming those objects exist and behave in a certain way. This practice is risky. Let's illustrate this with an example. Create a component called badButton. Now, create an instance of badButton in your application. When you click it, the window closes. It might seem fine because window is the ID of the application window in the same QML file. However, this approach carries several dangerous assumptions. The object window exists at the time the button is used. The object is of the expected type, application window. The object has the expected function or property, e.g. close. To avoid these assumptions and maintain clean component APIs, encapsulate logic and provide signals for external handling. This way, the component does not depend on external objects for its behavior. Transform badButton into a goodButton by moving the signal handler out of the component and into the instance. Create a goodButton component. Instantiate good button in your application. Add an onClicked handler directly to the instance. This approach ensures that the good button instance accesses the window object in its creation context, and the compiler verifies this, removing ambiguity. While subtle, this change is crucial for preventing incorrect assumptions. There may be cases where accessing objects by ID from within a delegate or component is necessary or even preferable. For instance, if you add a list view with a button delegate designed to close the window when clicked, you will need to ensure the component understands this relationship. In such cases, add pragma, ComponentBehavior, bound, at the top of the QML file. This tells the QML compiler that the ID in question is expected to refer to an object found within the QML file at runtime. Avoid using parent for property qualification. The parent property should be used sparingly, and only when you are certain that the parent will never change. An acceptable use of parent is when setting anchors such as anchors.fill parent, which is common practice when relationships are fixed. For example, create an item with an ID parent item and set. This usage is safe and appropriate in many scenarios where the relationship is well-defined and unlikely to change. However, avoid using parent for the root element of a QML file. Instead, use parent only on specific instances to ensure that anchors are evaluated within the scope of the component's reuse. Different usages of the same component may require different anchor configurations or none at all, especially if the component is used within a Qt quick layout. Be cautious when using parent for property bindings, even within a QML scope. For instance, add a property int value to the item and a text object that binds its text property to parent.value. If the object is refactored or reparented, the binding could mistakenly resolve to a different parent. This issue arises because the parent can change at runtime and may even end up being of a different type. To avoid this, reference the ID of the target object directly, ensuring the binding remains stable. In this case, change the binding from parent to parent item explicitly. In this section, we examined a persistent issue from Qt 5 that impacts Qt 6 migration, unqualified access. We defined the concept, explored various subtle ways it occurs, discussed its risks, and provided strategies for avoiding it. While the parent keyword can be convenient, we highlighted the importance of minimizing its use to prevent future portability issues in your code or that of others. QML files are intended to be reusable components, and their API should encapsulate properties and functions cleanly. By adhering to these principles, you create robust building blocks for application development that are portable and maintainable.